So we've discussed Fock space in a box. Now I want to discuss Fock space not in a box, but in infinite volume. In infinite volume. And as we've already discussed, everything inside these red boxes defines Fock space for us. This is all we've needed to do calculations. So for Fock space in an infinite volume, we're again going to have one oscillator for each k. So we'll again have an AK dagger and an AK. Now, however, k will be continuous. It will no longer be discrete. Okay, so let's maybe make a note here. K is now continuous. Okay, so that's an important thing to pay attention to. One thing that it will mean is we no longer have the Kronecker delta sitting there, but we would have a Dirac delta sitting here. And again, just to be super clear, the momentum K will have three components: an X component, a Y component, and a Z component. And when we write delta K minus P, we mean there's a product of three delta functions, one which sets the X components equal, one which sets the Y components equal, and one which sets the Z components equal. Okay? Then the commutator between AK and AP will still be 0. And the commutator between AK dagger and AP dagger will still be 0. We'll still have a state naught, that is the state of no particles. It will still be normalized to 1. AP will still kill ket naught, and AP dagger will still kill bra naught. So the only thing that we need to change in these red boxes is that the Kronecker delta becomes the Dirac delta, and then we have moved to infinite volume. Let's do a few computations just to get a little bit familiar with Fock space in infinite volume. So a single particle state would still be given by taking AK dagger and acting on ket naught. If you wanted a single particle bra state, that would be bra naught, and you'd act with AP. Now you can go ahead. This is a very simple computation. I'm sure you can do this. If you calculate the overlap between bra P and ket K, you will now get the Dirac delta, not the Kronecker delta. So that's the difference. So everywhere where you saw Kronecker deltas appearing, they will all now become Dirac deltas. The expression for the Hamiltonian also changes. You see, because K is now continuous, the sum over the discrete index must be replaced by an integral over the continuous index. So it'll be an integral d3p, omega p, of AP dagger AP. The formula for the momentum also changes, and in the same way. The integral, the sum over P is now becomes an integral over P. We have the momentum, an A dagger P, and an AP. You should take these states and try to, you should take these operators in Fock space and try to apply them to some Fock space states. Does it give you the correct energy? Does it give you the correct momentum? I am convinced that you know enough to carry out those calculations. We can also say how big is the Fock space. And the way that we would say it now, we would say if we have some operator, capital A, and if it commutes with AK and it commutes with AK dagger, then A should be proportional to the identity. And if A is Hermitian, then we know that lambda would even be a real number. Okay? And You would use this in much the same way that we use the similar looking statement for the harmonic oscillator to argue that our states obtained by acting with A daggers on ket naught are in fact a basis for Fock space. So they are a complete set, a complete linearly independent set of states for Fock space. Okay, so that's really Fock space in infinite volume. I want to encourage you to play around with Fock space, get familiar with it, and that's the way that you learn how to use it, by playing with it. Good. So the only thing left now, I want to have a little bit of discussion, give you a few hints for the exercises.